Hello everybody, Russian Nihilist here. So, I was in astronomy class today, and not only that, no, let me start over here. Um, Earlier today in woodworking class, we had a sub. They can't open up the woodworking room if they're subs, so we just got to sit on the computers. So I did some research on black holes, because that's what we learned about the day before in astronomy class. So here's what I thought up. I took some equations off of I just took some equations online, um, and I read about how black holes have a charge and about the event horizon and all that stuff. Then I did these equations, as you can see, to find the relation between the charge of the black hole and how it relates to the size of the event horizon. This can actually tell you where it has the radius of the black hole and to the edge of the event horizon. And I'm not sure if this is true because I don't know any really near black holes to test, but it's just the theory that I'm throwing out there. And another thing here is I was thinking, if a black hole has an event horizon, how does it do that? So it came up into my mind that maybe it has, because you guys know that if to actually become a black hole, you have to collapse into yourself. Well, not you personally, but you know what I'm talking about, right? When a star goes supernova, all this mass is usually clumped together really tightly. It's just really, really unbelievably dense. And a teaspoon of that could weigh as much as the sun itself if it collapses into a black hole. And since an atom is mostly void, you can imagine a whole stadium, a whole baseball stadium, put the baseball in center field, that's the nucleus, and then everything else, you put about maybe 10, 20 people in the seats, and those would be the electrons. Most of it's void. You clump that all together. Now, if you open up those electrons and protons and stuff like that, you know what else you get? More void. You have all those quarks in there, and still more void. Clump those together. You open up the quarks. We haven't named the things inside the quarks yet, but we can call it A and B. Okay, so there's A and B, and there's more void. You take that away, push those together, and it's even more compressed. It's just unbelievably dense. It's crazy. It just blows my mind. So, I was thinking, that since there's always going to be void, and sometimes that void doesn't get compressed, which determines the size of the actual black hole. So I was thinking of this void having, you can see it as a void core, and not the core itself is moving, but in my theory is that, let me think here. Let me think how I can demonstrate this to you guys. If I had a balloon, and then I put a little balloon inside, that little balloon inside is the void, but then everything else is fluctuating. Everything else is moving, it's going in and out. It's all weird while that void is moving, because there's the same amount of void in there. So, in my head, this is how things work out. Since this thing is going from place to place, at some points it could be less of a gravitational pull, and at some points it could be higher. And since it's just going so fast in there, since it's just moving at crazy speeds, depending on how quickly the thing rotates, that's what, in my mind, maybe, I'm not sure if this is right, okay? I think that is what creates the black hole's event horizon. I think that is just where gravity goes so fast that I can't even explain. So I'm just going to show you a little picture I drew, and these are some more calculations. Not the best. That's a really bad picture. That's supposed to be the void in there, and this is supposed to be the event horizon, the big circle. So since you have the big circle, if it's closer to this where there's more mass in between the 2 points, it releases more of it has more of a gravitational pull. And since you have less space up here in between, it has less of a gravitational pull. And this keeps on changing and changing and changing. So I think that it actually, in a way, gets all these, that event horizon is actually where both high and low gravity is there. And it's sucking everything in. It's just the entire gravity range as fast as this thing can go. So because of this, it creates an event horizon that as you pass it, nothing can get out because it's just going so quickly, and it's just a bunch of gravity. That's my thought on that. And I know that there's some mass there. That's why it has a gravitational pull because it has a mass. But so many things go into it. How can you keep all that matter in there? Well, the thing is, in some cases, depending on the size of the black hole, actually, you know what? I'll just leave that for another video, for another day. I'm gonna keep you guessing. Um, but see, once it reaches out the event horizon, it kind of, stabilizes because everything outside the event horizon is just like normal gravity here on Earth. It's stable, and I think that's where those gravity, uh, those fluctuations in gravity don't mix. They go on their own paths. So it's not where it's just this giant force of gravity. It's just a normal force. That's in my head. You know, that's what I was thinking. So tell me what you think, guys.